So, how do you take a website from zero all the way to millions of users? It's not some magic trick. It's actually a series of really smart, deliberate engineering steps. And in this explainer, we're going to break down that exact journey step by step.
Yeah, have you ever wondered about that? How an app goes from just a handful of users to, well, millions? The whole thing is this fascinating journey of solving one problem, which, you guessed it, just uncovers the next one. It's this constant cycle of finding and smashing bottlenecks.
You know, it all starts in the same place. I'm talking about every huge service you can think of. They all begin with the simplest setup imaginable. Just one server. Seriously. This one machine is doing everything. Running the app, holding the database, handling all the user traffic. The whole shebang. It's beautiful in its simplicity, but man, is it fragile.
And that fragility, well, it doesn't stay a theoretical problem for long. As soon as you get a bit of success and more users show up, that one server just gets completely overwhelmed. The CPU is maxed out. The memory is full. Pretty soon, the whole site just slows to a crawl. This is your first real growing pains. It's the system screaming at you that it's time to grow.
So what's the first move? You specialize. You split things up. We're going to separate the web server from the database. This creates what we call a web tier and a data tier. And this is a total game changer, because now we can scale each part on its own. If the website's slow, we beef up the web tier. If the database is choking, we focus on the data tier. It gives us options.
Okay, so speaking of that data tier, you immediately hit a huge decision. Are you going to go with a relational SQL database or a non-relational one, what we call NoSQL? Think of SQL as being perfect for really structured data, like neat tables and rows. NoSQL, on the other hand, is a beast at handling massive, messy, unstructured data at lightning speed. There's no single right answer here. It totally depends on what your app needs to do.
Right, so how do we actually get more power? Well, you've got two main options. First, there's vertical scaling, or scaling up. That's like taking your one server and just making it bigger and beefier, more CPU, more RAM. It's simple, but eventually you just can't make it any bigger. You hit a wall. The real secret sauce for huge apps is horizontal scaling, or scaling out. Instead of one big server, you just add more and more servers. This is how the big players handle millions of users.
Okay, so we've separated our tiers, which is great. But, we've just created a new problem. See that single web server? That is now what we call a single point of failure. If that one machine goes down for any reason, poof, the entire site is gone.
So, how do we fix that? With something called a load balancer. And honestly, the best way to think about it is as a super smart traffic cop for your website. It just sits out front of all your servers and directs the incoming traffic, making sure every server gets a nice, even share of the work.
And here's why that is so powerful. Look, now we have two web servers. The load balancer is spreading the traffic between them. But here's the magic. If server 1 suddenly dies, the load balancer sees that immediately and just sends all the new traffic over to the healthy server 2. Just like that, our single point of failure is gone. The site stays up. It's a massive leap in reliability.
Okay, awesome. We've made our web tier redundant, but take a look at our data tier. We've got the exact same problem, right? All of our web servers are still talking to one single database. And if that database goes down, well, the whole app grinds to a halt again.
The solution here is a technique called database replication. It's pretty much what it sounds like. We make copies. We set up one database as the master. Its only job is to handle writes, stuff like creating a new account or posting a photo. Then we create one or more slave databases that are just exact copies. All they do is handle the reads, like when someone is just browsing the site.
And this setup gives us 3 huge wins. First, performance goes way up. Most websites have way more people reading content than writing it, so we can spread all those read requests across our fleet of slave databases. Second, reliability. If a meteor hits a server, no big deal. The data is safe on another copy. And finally, high availability. If one of those slave databases goes offline, we just stop sending it traffic. The site keeps on running.
All right, so let's just take a second to look at what we've built. We've got a load balancer in front of multiple web servers. We've got a master database for writes and a bunch of slave databases for reads. We've systematically hunted down and eliminated our single points of failure. Our system is now way more reliable.
But you know how it is. Just being online isn't enough anymore. People expect things to be fast. So our next big hurdle is performance. How do we make this thing fly? How do we make every click, every page load feel instant?
Well, the first part of the answer is a cache. Think of a cache as your system's super fast short-term memory. Instead of going all the way back to the database every time, which is kind of slow, the app first checks the cache. If the data it needs is right there, it gets it back instantly. And when I say instantly, I mean it. It's a massive speed boost.
So a cache is awesome for data that changes a lot. But what about all the static stuff? You know, the images, the videos, the big script files. For that, we need an even bigger gun, a content delivery network, or CDN.
So what is a CDN? It's basically a massive, worldwide network of cache servers. The whole idea is to get content physically closer to your users. So if someone in, say, Tokyo requests an image, they're not pulling it from your main server in New York. Nope, they're getting it from a CDN server right there in Tokyo. That simple change in distance makes a huge difference in loading times. The site just feels snappy no matter where you are in the world.
So let's look at our system now. We've got the CDN out front, handling all those big static files. Then we have our cache, which is grabbing all those frequent data requests before they even hit the database. What these two layers do is act like a giant shield, protecting our main servers and databases from a ton of work. The whole system is just faster, and it can handle way more traffic.
Okay, this next concept is absolutely crucial for massive scale. It's the difference between stateful and stateless architecture. A stateful server is, well, it's clingy. It remembers things about you, like your session info. A stateless server has amnesia. It remembers nothing. Every single request you make is like it's meeting you for the first time. All that important stuff, like what's in your shopping cart, gets stored somewhere else, like in a shared database.
So why on earth would we want our servers to be forgetful? Because it makes them completely interchangeable. Think of them like cattle, not pets. Since no single server holds any unique critical user info, we can add new ones or get rid of old ones whenever we want, all based on the current traffic. This is called autoscaling, and it's the key to handling huge, unpredictable spikes in users without breaking a sweat.
All right, we've got a fast, reliable, and stateless system. Now it's time to take this show on the road, globally. What we do is take our entire setup, the whole thing, and just replicate it in multiple data centers across the world. Then we use a clever routing service that looks at where a user is coming from and sends them to the data center that's physically closest. That means a user in Europe talks to a European server, and a user in Asia talks to an Asian server. Everybody gets the fastest experience possible.
Okay, but now our system is getting pretty complex, right? We have services all over the planet that need to talk to each other. How do they do that without getting bogged down? The answer is a message queue. Think of it like a to-do list between services. For example, when you upload a photo, the web server doesn't have to wait around while it gets resized and filtered. It just drops a message into the queue that says, hey, process this photo, and moves on. Some other service will pick up that message and do the work later. This makes our whole system way more resilient because services aren't waiting on each other.
Wow, okay, let's just quickly recap this whole journey. We started with just one lonely server. Then we separated the database, brought in a load balancer, and replicated our data to make things reliable. Then we added a cache and a CDN to make it fast. We went stateless so we could scale easily, expanded to multiple data centers to go global, and finally we added message queues to make the whole thing resilient. What a transformation.
So we've come a long way. But here's the thing about scaling. It never, ever stops. It is a constant, looping process of finding the next bottleneck and figuring out a smart way to fix it. So I'll leave you with this. Looking at this complex, global system we just built, what do you think the next bottleneck is? Where's the next weak spot? Because that's the exact question that engineers at this scale wake up and ask themselves every single day.